The true measure of technological progress isn't found in the complexity of what we can build, but in the simplicity of how people can use it. In the realm of artificial intelligence agents, this principle has never been more critical. As AI systems become increasingly sophisticated, the challenge lies not in their computational power, but in making them accessible, transparent, and manageable for everyone. From the small business owner seeking to automate customer service to the healthcare professional wanting to enhance patient care, the democratization of AI through user-friendly design represents a fundamental shift in how we conceptualize human-machine collaboration. Today's AI agents are designed with the understanding that their ultimate success depends not on impressing technical experts, but on empowering ordinary people to achieve extraordinary results. This transformation requires careful attention to three fundamental pillars: intuitive usability that eliminates technical barriers, transparent decision-making that builds trust and understanding, and robust human oversight that ensures quality and maintains control. The evolution of AI agent usability represents one of the most remarkable achievements in modern technology design. A study by Topdal in 2024 indicates that AI chatbot reduced average response times to common support questions by 40% and decreased the volume of support tickets handled by human agents by 30%. This dramatic improvement in efficiency stems not from complex programming, but from intuitive design that makes AI agents as easy to manage as familiar business tools. Intuitive interface design forms a foundation of modern AI agent usability. Gone are the days when deploying an AI system required teams of data scientists and months of technical implementation. Today's platforms present users with visual, drag-and-drop interfaces that feel as familiar as arranging slides in presentation or organizing files on a desktop. Users can define agent behaviors, set decision rules, and configure responses through simple point-and-click actions, transforming complex machine learning concepts into visual workflows that anyone could understand and modify. One-click deployment and setup eliminates the traditional barriers to AI implementation. Modern AI agent platforms provide pre-configured templates for common business scenarios, customer service, appointment scheduling, inventory management, and lead qualification, allowing users to deploy functional agents within minutes rather than months. These templates serve as starting points that can be customized without requiring deep technical knowledge, much like customizing a website theme or adapting a document template. Natural language configuration enables users to communicate with their AI agents using plain English rather than programming languages. Instead of writing complex code to define agent behaviors, users can simply describe what they want their agent to accomplish. When a customer asks about pricing, provide our current rate sheet and schedule a follow-up call if they're interested in enterprise solutions. The platform translates these natural language instructions into the sophisticated logic that drives agent behavior. Real-time monitoring and analytics provide continuous insight into agent performance without requiring technical expertise to interpret results. Dashboard interfaces display key metrics, response times, resolution rates, customer satisfaction scores, in visual formats that make trends and issues immediately apparent. Users can identify when agents need adjustment and understand the impact of changes they make, creating a feedback loop that enables continuous improvement. Automated maintenance and updates minimize the ongoing technical burden of AI agent management. Unlike traditional software that requires manual updates, security patches, and performance optimization, modern AI agents automatically update their knowledge bases, improve their responses based on interactions, and adapt to changing conditions. This self-maintaining capability means that even small organizations without dedicated IT staff can deploy and operate sophisticated AI systems. Progressive complexity allows users to start simple and add sophistication as their needs and comfort levels grow. A restaurant owner might begin with a basic reservation system that handles booking requests, then gradually add features like menu recommendations, dietary restriction management, and integration with inventory systems. This approach prevents overwhelming new users while providing a growth path for those ready to explore advanced capabilities. Multi-device accessibility ensures that AI agent management isn't confined to desktop computers or specific software platforms. Users can monitor, configure, and troubleshoot their agents from smartphones, tablets, or any web browser, providing the flexibility needed for modern business operations. This accessibility is particularly valuable for small business owners and entrepreneurs who need to manage their operations from anywhere. Community-driven support creates ecosystems where users can share templates, troubleshooting tips, and best practices. Rather than relying solely on technical documentation, users can learn from others who have solved similar problems, access pre-built solutions for common scenarios, and contribute their own innovations back to the community. This collaborative approach accelerates learning and reduces the isolation that often accompanies technology adoption. Transparency in AI decision-making has evolved from a nice-to-have feature to an essential requirement for building trust and ensuring accountability. Explainable AI seeks to shed light on the often opaque processes behind AI decisions, making these processes clear and understandable for everyone. This transparency is paramount in high-stake areas where AI's decisions can significantly impact individuals and society. Explainable AI architecture forms the cornerstone of transparent agent design. Modern AI agents are built with explainability as a core feature rather than an afterthought. When an agent makes a decision, whether to escalate a customer service issue, recommend a product, or flag a potential security concern, provides clear explanations of the factors that influence that decision. These explanations are presented in natural language that non-technical users can understand, bridging the gap between complex algorithmic processing and human comprehension. Decision audit trails create comprehensive records of every choice an AI agent makes, along with the reasoning behind each decision. Users can trace back through an agent's decision-making process to understand why specific actions were taken, what data was considered, and how different factors were weighted. This capability is particularly valuable for regulatory compliance, quality assurance, and continuous improvement efforts. Confidence scoring and uncertainty communication help users understand when an AI agent is operated within its areas of expertise versus when it might be making educated guesses. Agents indicate their confidence levels for different decisions and recommendations, allowing users to make informed choices about when to trust agent recommendations and when to seek additional input or verification. Real-time decision visualization transforms abstract algorithmic processes into visual representations that users can observe and understand. Decision trees, influence diagrams, and interactive flowcharts show how information flows through the agent's reasoning process, making it possible for users to identify potential issues, understand system behavior, and validate that agents are operating as intended. Bias detection and mitigation tools automatically identify when AI agents might be making decisions based on inappropriate criteria or exhibiting systematic biases. These tools flag potential issues, explain their significance, and provide guidance on how to address them. This proactive approach to bias management helps ensure that AI agents make fair and appropriate decisions across different user groups and scenarios. Customizable explanation depth allows different users to access different levels of detail about agent decision-making based on their needs and technical sophistication. A business executive might want high-level summaries of agent performance and key decisions, while a quality assurance specialist might need detailed technical explanations of specific algorithmic choices. The same transparency system can serve both needs without overwhelming either user type. Interactive what-if analysis enables users to explore how changes in input data or decision criteria would affect agent behavior. Users can simulate different scenarios, test edge cases, and understand the boundaries of their agent's decision-making capabilities. This functionality supports both system validation and user education about agent behavior. The concept of human-in-the-loop AI design recognizes that the most effective AI systems are those that enhance human capabilities rather than replacing human judgment entirely. It requires a human in the loop. 1. To test consistency of the model with the domain knowledge, and 2. To ensure reliable and trustworthy models. It is especially important for high-stakes tasks, for which incorrect decisions lead to significant harm to individuals or society. Escalation protocols and thresholds ensure that AI agents recognize when situations exceed their capabilities and seamlessly transfer control to human operators. These protocols are not simply binary on-off switches, but sophisticated systems that consider multiple factors: complexity, risk level, confidence scores, and stakeholder impact to determine when human intervention is needed. Users can customize these thresholds based on their specific requirements and risk tolerance. Continuous monitoring dashboards provide real-time visibility into agent performance, enabling proactive human oversight rather than reactive problem-solving. These dashboards highlight anomalies, performance degradation, unusual patterns, and potential issues before they impact customers or business operations. Human operators can intervene at the first sign of problems rather than waiting for failures to occur. Human feedback integration creates systematic mechanisms for human operators to provide ongoing guidance and correction to AI agents. When humans override agent decisions, correct agent responses, or provide additional context, this feedback is automatically incorporated into the agent's learning process. This creates a collaborative relationship where human expertise continuously improves agent performance. Quality assurance sampling implements systematic review processes where human operators evaluate random samples of agent interactions and decisions. This statistical approach to quality control ensures comprehensive oversight without requiring human review of every agent action. Quality metrics, trend analysis, and exception reporting help identify areas where additional training or adjustment might be needed. Emergency override capabilities provide multiple mechanisms for immediately stopping or redirecting agent behavior when necessary. These safety mechanisms include emergency stop buttons, rapid reconfiguration options, and the ability to instantly switch to human-only operation. Such capabilities are essential for maintaining control during unexpected situations or when agents encounter scenarios they weren't designed to handle. Collaborative decision-making frameworks enable AI agents and human operators to work together on complex decisions that benefit from both artificial intelligence capabilities and human insight, rather than fully automated or fully manual processes. These frameworks create structured collaboration where agents provide analysis, recommendations, and data processing while humans contribute judgment, creativity, and contextual understanding. Training and calibration interfaces allow human experts to actively participate in improving agent performance through structured training sessions. Domain experts can review agent decisions, provide corrections and guidance, and help refine decision-making criteria. This process ensures that agents learn not just from data, but from human expertise and institutional knowledge. Approval workflows for high-stakes decisions require human authorization before agents can take actions with significant consequences. Financial transactions above certain thresholds, changes to critical systems, or communications with key stakeholders might require human approval even when agents are capable of handling these tasks independently. These workflows provide an additional layer of control and accountability. Performance analytics and human impact assessment measure not just how well agents perform technical tasks, but how effectively they collaborate with human team members. Metrics include time saved for human workers, job satisfaction scores, error rates in human-agent collaboration, and quality of escalated issues. This holistic view ensures that AI implementation enhances rather than hinders human performance. The convergence of intuitive usability, transparent decision-making, and effective human oversight creates AI agents that truly serve their users rather than mystifying or replacing them. Recent advances in agentic AI bring that autonomous future a step closer to reality. With their supercharged reasoning and execution capabilities, agentic AI systems promise to transform many aspects of human-machine collaboration. Small businesses report that well-designed AI agents become natural extensions of their teams rather than foreign technological intrusions. A family-owned medical practice might deploy an appointment scheduling agent that not only manages bookings but learns the preferences of regular patients, accommodates the scheduling preferences of different physicians, and handles the complex insurance verification requirements that consume significant staff time. The agent's transparency allows staff to understand and trust its decisions, while human oversight ensures that complex or sensitive situations receive appropriate attention. Educational institutions find that transparent AI agents enhance rather than threaten the role of educators. An AI tutoring agent might identify learning gaps, provide personalized practice recommendations, and track student progress while maintaining clear visibility into its decision-making process. Teachers can understand why the agent makes specific recommendations, override suggestions when a professional judgment differs, and use agent insights to inform their instructional strategies. Nonprofit organizations leverage user-friendly AI agents to amplify their impact while maintaining the personal touch that defines their missions. A volunteer coordination agent might match volunteers with opportunities based on skills, availability, and interests while providing clear explanations for its recommendations. Staff can easily modify matching criteria, override suggestions based on personal knowledge of volunteers, and ensure that the human relationships at the heart of nonprofit work remain strong. Future directions and emerging trends. The field of AI agent usability and maintenance continues to evolve rapidly, driven by user feedback, technological advancement, and growing understanding of human-AI collaboration. Designing fair and transparent human-AI interactions can lead to the involvement of human users to the decision-making, learning, and adaptation process of an AI system for several reasons. Conversational agent management represents an emerging trend where users interact with their AI agents through natural language conversations rather than traditional interfaces. Users might say, "I want you to be more proactive about following up with customers who haven't responded in 3 days," and the agent would understand and implement this guidance without requiring interface navigation or configuration settings. Predictive maintenance and self-optimization advance beyond current automated maintenance to systems that anticipate future needs and proactively adapt to changing conditions. Agents might recognize seasonal patterns in customer inquiries, anticipate increased demand during specific events, and automatically adjust their response strategies and capacity allocation. Cross-agent learning and collaboration enable AI agents from different organizations and industries to share insights and improvements while maintaining privacy and confidentiality. A customer service agent deployed by a small retailer might benefit from patterns learned by agents in similar businesses, accelerating improvement without compromising competitive advantages. Augmented reality agent interfaces provide new ways for users to visualize and interact with their AI agents' decision-making processes. Instead of traditional dashboard interfaces, users might see three-dimensional representations of data flows, decision trees, and performance metrics that make complex information more accessible and actionable. The future of AI agents lies not in their technical sophistication alone, but in their ability to serve as intuitive, transparent, and collaborative partners for people from all backgrounds and industries. Transparent AI systems can enhance cybersecurity by making the underlying decision-making processes understandable and verifiable, thus fostering trust among users. The greatest innovations in AI agent design are those that make complex capabilities feel simple, mysterious processes feel transparent, and autonomous systems feel controllable. When a small business owner can deploy, understand, and maintain an AI agent as easily as they manage their social media presence, when healthcare workers can trust AI recommendations because they understand a reason behind them, and when educators can collaborate with AI tutors while maintaining oversight and control, we witness the true democratization of artificial intelligence. The journey toward perfectly usable, transparent, and human-centered AI agents continues, driven by the recognition that technology succeeds not when it impresses experts, but when it empowers everyone. The future belongs to AI systems that amplify human capabilities while remaining firmly under human control, systems that explain themselves clearly while solving problems efficiently, and systems that anyone can use effectively regardless of their technical background. Your opportunity to participate in this AI revolution has never been more accessible. The barriers have been lowered, the tools have been simplified, and the support systems are in place. The question is not whether you can successfully deploy and manage AI agents. It's what problems you'll choose to solve and what improvements you'll bring to your corner of the world. The age of accessible, transparent, and human-centered AI has arrived. Your intelligent assistant awaits your guidance.
Thank you for